You've probably seen the headlines: possible signs of life detected, breakthrough discovery hints at aliens. It seems like every few months there's another exciting announcement. But how promising are these discoveries really? If you're like most people, it's hard to tell which ones are truly groundbreaking and which are just media hype. Today, we're going to rank every major potential sign of life beyond Earth, from the most promising to the most dubious. Let's do this in chronological order, starting way back in the 1800s and racing up to discoveries hot off the telescope. First on the list, the so-called Canals on Mars. In the late 1800s, astronomers peering through small telescopes thought they saw straight lines crisscrossing Mars's surface. Some folks believed these were artificial waterways, built by an advanced civilization desperate for water. Others talked about seasonal color changes that might be alien crops. Sadly, better images showed there are no canals, just illusions and dust storms. Today it's considered a classic case of wishful thinking. So those Martian canals belong in our F tier right at the bottom for historical curiosity only. Next stop, 1976. NASA's Viking landers touched down on Mars with experiments to test for life in the Martian soil. One of them, called the Labeled Release Experiment, got a startling result. When the lander mixed nutrients into the soil, it measured a surge of radioactive gas as if something were metabolizing. Could it mean Martian microbes, alive and munching? Well, the other Viking instruments found no organic compounds at all, so scientists chalked it up to weird soil chemistry, no little green bugs. Today that result is mostly seen as a false alarm. But it's still intriguing enough to give it a slightly higher spot. Let's call that D tier. Big deal at the time, likely not actual aliens. Also in the 1970s and 80s, NASA's Galileo mission was getting underway, and by the 1990s, it revolutionized how we see Jupiter's icy moons. One target, Europa. Data showed Europa has a global saltwater ocean beneath its ice shell. That means a hidden liquid sea with possible hydrothermal vents, similar to those teeming with life on Earth's ocean floor. We haven't found direct proof of living cells there, but scientists consider Europa a prime candidate for microbial life. For now, it's only an indirect sign, no specific molecule or microbe that screams alien. Still, it's a legit place to look, so let's slot Europa in a mid-range tier. Let's call that C tier. Definitely promising in the where we should explore sense, but not a direct detection of anything living. Not long after, in 1996, the world was stunned by claims about a Martian meteorite called ALH84001. Microscopic structures inside were thought to be fossils of ancient Martian bacteria. The President of the United States even made a speech about it.
It speaks of the possibility of life. If this discovery is confirmed,
then scientists dug deeper and found non-biological explanations for every clue. The shapes were too tiny to be real microbes. The chemical signals were likely formed by basic geology. So these microfossils turned out to be another false lead. Into the F tier it goes. Interesting rock, but no aliens within. Skipping ahead to the early 2000s, astronomers began reporting methane in Mars's atmosphere. On Earth, methane mostly comes from living organisms, and it's unstable, so if it's lingering on Mars, something might be replenishing it. Over the years, NASA's Curiosity rover measured seasonal fluctuations in the methane concentration, plus mysterious spikes that appear and disappear. Could that be microbial burps from below the surface? Or maybe it's just chemical processes in Martian rocks or leftover methane trapped in ice that occasionally escapes. The evidence is strong that something is producing methane, but we have no clue if it's geological or biological. Let's be safe and call this a B tier. It's a true enigma, definitely not guaranteed alien life, but intriguing enough to keep us looking. Then came 2005, when the Cassini spacecraft flew by Saturn and discovered that little Enceladus, just hundreds of kilometers wide, spews water-rich plumes from an ocean under its icy crust. Cassini's instruments found methane, organic compounds, and even phosphorus in those geysers. That is huge, because on Earth, hydrothermal vents plus water plus organic molecules often equal living ecosystems. While it might be explainable by strange geology, it's tough to make as much methane as Enceladus's vents seem to pump out without something biological helping. So that catapulted Enceladus into the top ranks, and scientists everywhere went, wait, is there an entire alien microbial ocean in there? We haven't confirmed it, but we're definitely excited. That's an S-tier contender if ever there was one. Around 2010, Saturn's big moon Titan also raised eyebrows. Titan has a thick, smoggy atmosphere loaded with organics, plus lakes and seas of liquid methane. Cassini found that hydrogen gas and acetylene on Titan weren't showing up where models predicted, hinting that something might be eating them. If that's life, it'd be the strangest life we've ever imagined, because Titan is so cold that water is basically rock-hard ice. Most scientists think it's more likely exotic chemistry, but the puzzle stands. We'll put Titan in about the same territory as Europa, so in a C tier. Fascinating environment, definitely a place to check, but no smoking gun. A more recent puzzle from Mars again appeared in 2019. Curiosity found that the oxygen levels in the Martian air mysteriously rise and fall in ways we can't explain. On Earth, that might be tied to photosynthesis in warmer months. On Mars, we don't have enough evidence to shout algae. It's probably some quirky surface chemistry. So that's going to hang out in D tier with Viking's earlier results. Odd, but not a strong bet for little Martians. Just a year later, in 2020, a team announced possible phosphine gas in Venus's clouds. Normally, on a rocky planet with lots of oxygen around, you wouldn't expect phosphine unless microbes or factories were making it. That triggered a massive debate. Some rechecks of the data can't find phosphine at all, while others say they still see a small signal. Maybe there's a sliver of phosphine up there, maybe it's an error, maybe it's some weird volcanic process we haven't identified. So it's controversial. But if phosphine is really there in the amounts first proposed, that's a pretty good candidate for biology. Let's bump it above the Mars methane puzzle, so call that an A tier, because if confirmed, it would be a huge deal. But as of now, we can't be sure if the gas is even present. Finally, in 2023, K2-18b stole the headlines. It's a strange exoplanet about 120 light-years away, possibly with a hydrogen-rich atmosphere and hints of methane and carbon dioxide. Then astronomers announced a tentative detection of dimethyl sulfide. On Earth, nearly all DMS comes from living organisms in the ocean, mainly plankton. If that's real and not some data glitch, it's exceptionally difficult to explain through pure chemistry. That said, the detection is super preliminary. More observations are needed before we pop champagne. But if it holds up, it might be the clearest biosignature we've ever seen off our world. So K2-18b sits at the top of our entire list in S tier, narrowly edging out Enceladus for the best current hope. Right now, as you're watching this video, light from K2-18b that left its alien oceans 120 years ago is just reaching our telescopes. In the time it took that light to cross space, we humans invented powered flight, split the atom, and landed on the moon. And now, that ancient light might be telling us we're not alone. What will we discover in the next 120 years?